I work with the real experts, and yeah, I feel like a mouse compared to them. But yeah, I do in the business of signing worldwide. I've been involved quite a bit. But thank you very much for that introduction. Okay, so I think I'm just going to jump straight into it. I just before I begin, I just want to say that the background of what I'm trying to do here is that I being in the business of effectively selling signatures is I kept having to explain the same thing over and over, even to senior developers. So if you are so I decided to put this talk together from a perspective of I really want to explain it in a way, the ideas behind signing, why you want to sign, how signing works, from a really bottom up, but on an idea level. So that I hope that everybody who walks away from here will understand what digital signatures are all about and why you want to use them. And then you can go and learn more and you'll understand what you're reading. That's the idea. There's only that much you can do and you can talk about in a talk like this, but you'll see I'm trying to really cover as much as I can. Okay, so just my disclaimers. I've already had two now. This is not a dive into algorithms. I wanted to be talking about ideas and not technologies so much. I'll be telling some white lies, but I will point them out. That's just to explain the ideas. I'm not a cryptography expert. Cryptography experts typically you don't see them because they never leave their house, and they definitely don't switch their cameras on. So so I just wanted to point that out. Okay, so to start the talk,
Stephan, I think
yes.
you mean to be sharing your screen, right?
I thought I'm sharing. I would have been going on and on, Alex.
Awesome, got it.
Okay, so here's what I was. So this was my sign to be signed. Everybody can see, right? Okay, great. Okay, so sorry, just Zoom is now covering my own screen. Okay. Okay, so to begin the chat, I want you to think of important documents. Think of a ID or a passport or anything that is, so we typically use the word a high value document or a high integrity document. These are typically the things that you need to think about. But for my example, I'll be talking about the matric certificate, right? And when do you use a matric certificate? When you apply for a job. And these things get forged all the time. And so, you have to imagine now you have an employer. I just want to make sure you guys can see my cursor, right? Okay, that's very important. So you're the employer, and somebody rocks up in front of you, and okay, cool, I've got this qualification. Now, how do I, as the employer, know that this thing is real? Has it been tampered with? Is it even real? This is what we could call either the integrity or the authenticity. Integrity, has it been photoshopped? Or authenticity, did this thing really, did the Department of Education issue something like this at all? Now, I mean, what's your options? You can call the department. Good luck with that. Okay, so for some reason, the department or people think you can just put a signature on there, and that's Photoshop proof or something. Okay, great, solves nothing. The police seems to think a stamp works, especially if they add another scribble on it. So that doesn't really solve any problems. So and other institutions say, okay, well, security features, oh, this is the thing with the watermark, or this is the thing with a hologram. At least this has some value because it shows that this is the original. But the fraudsters are really good at making changes on documents. Some of the examples I've seen are ridiculous. So So it can show you that it's the original, but it's really hard to detect if this thing has been tampered with, and therefore is the integrity intact, and therefore is it still authentic? Sorry for repeating these words all the time. So the key words here are authenticity, integrity, and originality. Okay, so what's our options to solve this? Well, one solution is you can use a cloud type of solution. Another solution is, well, you can use a type of file security in your file format. In other words, you can do a PDF signing, which I'll talk about that in a bit. Other solution is you can include the signature on the actual document you're inside in some kind of barcode or something like that. So I'm just going to run through those options a little bit more in detail. So, the online option, you can have a barcode on on your document, and you can scan the barcode and it takes you to some URL. The URL renders you a copy of the document. And I mean, that works great. And so this is now your phone, and it accesses some web server in the background, accesses the database. Yeah, there's there's a lot of solutions like that, but there's some problems with this. Well, first of all, you need internet. Other one, databases get hacked all the time. I know if you've talked to the suppliers here, our security is so amazing, our security is so amazing. Just open the news to see who has been hacked this week. And then there's also regulation and privacy issues. Where are you storing it? Who has access to the information? And when you're talking about really high value documents like proof of payments, companies are not interested, banks are not interested in the solution. They're not going to keep a copy of every proof of payment or let some other provider do that for you. Okay. So anyway, that's one option. Just another issue with the online solution is that you have some kind of URL in there which can very easily be spoofed. The hacker can just change the barcode to point to some other website which has a mock-up of the document, and then the thing looks as real as day. So these are just some examples of types of problems you have. Okay, so the other option, you can do PDF signing. Okay, so I'm going to go into the details of signing in a bit, but I'm just rushing over this very quickly. You're always during the presentation, you'll spot this mistaken presentation. My logo is not supposed to be there at all. Just ignore that. Anyway, so you have a PDF file. So this block here, imagine this is a PDF file. Then the PDF file contains the document, and at the bottom, it depends on how you structure, blah, blah, blah. But basically in the document, it has a type of footer, and in there, it stores digital signatures that protects the rest of the document from tampering or anything like that. And then, when you verify it, you can tell if this thing has been tampered or not. And you can also check the authenticity. It works great for electronic media. But if somebody puts a paper in front of your desk, this just doesn't work. Okay. So the other solution is to embed the security. And this is what my company does, TrueVolve Technologies. We have done some. We actually come out of the number plate business, which is a little bit a strange industry, and we're moving into other businesses to secure documents. And we have been involved in developing an ISO standard called ISO IEC 2248, which is it's a whole mouthful. I'm just going to say very briefly. It's probably going to go over a lot of people's heads, but you'll get there. But very simply, it's a standard that tells you how to encode data in a standardized way, and encode and sign in a very specific and minimalistic way, so that other vendors can also decode it, and things like that. So it's very for things like government documents and such, when you have tenderized systems, and standards are very important. This is typically where it's used. I'm not going to talk about this much more today. If you want to know more, send me an email. Okay. Truevolve Technologies. By the way, we're hiring right now. You can see our website. We will be on Office in Active as well. Okay. So to explain signatures, I'm gonna have to explain two ideas, and these ideas I'm gonna explain them in quite an abstract way, and I hope that it works. I haven't tried it with anybody really, so we'll see. I want you to imagine office work 3000 BC, right? And your job is you're a scribe, and somebody hands you this holy scripture, right? And you have to make copies of this thing. And let's read the scripture. You know, this scripture is very important. You must make perfect copies of the scripture to ensure that future generations can obtain the divine knowledge revealed to us during prayer and meditation. Failure to make perfect copies will result in your eternal punishment. Behold the truth. Dogs are cool. Okay, great. This is the scripture. Now, you have the original and you have to make a copy. So, and you know, you're right, you're copying with this chisel or with a, you know, little paintbrush. And you make a copy, and now you have to make a mistake. Now, if you're only making one copy, it's, you know, it's quite easy. You just go through it carefully. But if you're making 100 copies, it's really easy to make a mistake. So you come up with a plan. You say, okay, let's assign a number to every character we use, right, in the scripture. And you know, everybody has done this in high school with some messages or making a secret code or something. So, or that maybe just types of things I did when I was in high school or primary school, whatever. And you just assign a number to every value, and then you go on your scripture, and in a pencil, you literally just add all the values together. Okay, and then you come up with an answer for your line. Okay, and you do that for every line, and you just count all the values together, and there you come up with a value. Okay, now, and so it's a kind of number that digests the content that you copied. So you did this on the original now, and you know this value, this hash value of your original is 3198. Great. And you just do the same thing for your copy, and you see that these two values are the same. And then, hey, that makes me so confident that I didn't make a mistake. Now, if you think about it a little bit hard, you'll understand there's flaws in the scheme, but I want to explain the idea, and most people seem to understand this idea. So this is also called a checksum, although technically that's maybe slightly something else, but that's one of my white lies. This is a hash for argument's sake. Okay, so if you made a copy, so dogs are cool, and it said cats are cool in the copy, then the two values are not the same anymore. And so you know this copy has been tampered with. And if you go through it line by line, you know, you can check the value on each line, and you can find out which line has been tampered with. Okay, so this is just a little bit of a joke. I was wondering how what horizontal scaling looks like in 3000 BC, but I couldn't come up with a picture what vertical scaling looks like. So if anybody has an idea on that, please tell me. Okay, so integrity checking is very simple. You have your first data set, you have a data set, you do some kind of function on it, and you get a hash. You take your other data set, you do the same function on it, and you get a hash again. You compare the two hashes, and that's how you know if your integrity of the document has remained intact. In other words, if your copy has been modified. Okay, so just very simply, I just want to give you some examples. You know, you have that this example I used where you just add all the numbers together, that's too simplistic. There are other hashing functions that's more real, but you'll see the answer is typically presented in hex. And you know, the different hashing functions are different lengths. But if you really want to understand hashing, go and see the talk Skulk made a couple of weeks ago, months ago. Hash would be hashed. He explains everything in amazing detail. I thought he did an excellent job. Okay. I hope you guys understand what I mean with hashing, and you got the idea of checking integrity. Okay, now, next idea I want to explain is asymmetric encryption. Okay, so before I go in, normal encryption, I hope you guys understand it, but if for those that don't, if you zip a file and you put a password on the zip file, that is symmetric encryption. That's normal encryption. What we're going to talk about here is asymmetric encryption. It works just a little bit differently. Asymmetric encryption, they are you generate keys. Keys gets generated from random data, but you use a specific system depending on the algorithm you use, the rules you use, the system you use. But they are always in an asymmetric environment. There are always two keys. Okay. And you should see them as siblings or twins or something. Okay, but not twins. It's more like siblings. They're not the same. Okay, and these keys have this very interesting property. That okay, just take note that I'm drawing the one key looking down and the other one looking up, just to differentiate between them. So these keys have this key has this very interesting property that if you take data and you encrypt it using the one key, okay, then you get, this is now the encrypted data, and I say that this has been encrypted with this data, with this key. Then if you try and use the same key to decrypt the data, then you get an error. It doesn't work. You have to use the sibling, the other key, to decrypt the data. Okay, and for RSA, which is an asymmetric algorithm, you can swap these keys around. So if you encrypt it with the other one, you can once again read it with the other one. So that's a very important concept to understand. But I'll explain it a little bit more. So what we're going to do is we have these two keys, and we just give the one, and we just give them labels, you know, key rings. Say, hey you are the you are the private key, and you are the public key. Okay, so let's talk about Alice. We say Alice, she keeps the one key, the private key, and everybody else, like everybody, you paste it on your, she pastes it on a Facebook, she emails it to everybody, everybody else gets the public key. Okay, and so, and now what I did, I just put this little picture of Alice's face everywhere where her public key is. So if somebody takes, if somebody takes Alice's key and they lock it, and they write a message and they lock the message using this key of Alice, the public key, then only Alice can read it. So anything encrypted with a public key can only be read by Alice because she has the private key. Okay, only I can read this message. Now look, these arrows now point the other way. If Alice writes a message, okay, then only, if Alice writes a message and she locks it with her private key, then everybody can read it. That's it. That's a thing that a lot of people don't understand. Okay, so I hope you guys got that. Okay, so I'm just going to go. So anything public key can only be decrypted. Anything encrypted by the one key can only be decrypted by the other key. Correct. So digital signatures is the scheme where we put these ideas together. And so you guys remember this guy. Okay, forget him. I want you to remember Alice. Alice and her private key. And also, but also think of this hash that we made here. Now I'm using the simplified one just to keep the story simple. And what Alice does is she takes this hash value here, and she encrypts the value using her private key. And then she writes the answer at the bottom of the scroll. Okay, now this is written in base64. Okay, so what does this mean? Well, guys, this is how a digital signature is made. It's an encrypted hash. It's a hash that has been encrypted using a private key. So let's see, let me tell through the story. So if a member of the public, if somebody who has Alice's key, now I'm not going to go into the details, I don't have time for going into the details of how somebody can be sure they really got Alice's key. Let's just say she gave it to them personally. So anybody who has Alice's key can now take this digital signature, this encrypted value, and they decrypt it and out pop the hash. So, it's this hash that was originally on the document. So then that's step one. Step two, now somebody can go, the person who wants to verify this document can go, and they do these calculations. They calculate the hash of the document themselves. And then they can compare the two values. And if they are the same, they know that this definitely comes from Alice. Okay. So let's say some, criminal goes and he changes the Holy Scripture. He says, cats are cool, blasphemy. And so let's follow the same process. These guys, they received this copy of the document that says cats are cool. They decrypt the digital signature and they come up with a value. Now they calculate the hash themselves, and now they come up with a value that's different from the one that was stored inside the digital signature. Okay, so this is how they know this thing comes from a criminal, and this document was definitely tampered. So when you guys work with technologies like JWT or which is in OAuth, or when you guys look at our technology, all these things in principle use these ideas. Okay, so so if you think about what we were just talking about, we said encryption scheme typically includes an encryption algorithm and a hashing algorithm. Okay, now these days people don't really make signatures with RSA anymore. RSA is the classic asymmetric encryption algorithm. We're not going to go into that. These are the more popular algorithms. These the block Bitcoin uses ECDSA with SHA-256, I believe, for solutions that don't need that much performance, that people feel more secure about. They like to use the SHA-3 version, but yeah, these things are typically. There's hundreds of algorithms and there's hundreds of signing schemes, and I can talk about the ones I know about quite a bit. But in general, what you should know, what you should know is that people care about the following things. They care about the signature length. The signature length is literally how many bits is the signature that gets written at the bottom. Okay. Now, typically these things get rendered as a QR, or if it gets rendered on a document or some other barcode technology. But in RFID and all of these other technologies, there's limited memory space on how you want to, on where you can write the signature, which is something to think about. There are other algorithms. So the first one, you care about the signature length. You care about the performance, and something like Bitcoin, you know, these like thousands and thousands and thousands of signatures need to be generated in a second. So you need to have something that's really performant. The strength, now that you should know that the strength of an algorithm is merely an opinion. It's really hard to mathematically calculate the strength of an algorithm. Now, I'll briefly explain what they mean. When people say, when they say estimated at 100, what they mean is they think it will take 2 to the power of 100 operations to crack this signature. And you have to understand that, there doesn't seem to be, you think 100 and 112. Trust me, there's a huge difference between 100 and 112. That extra 12 makes all the difference. Okay, and the last thing is the politics and the trust. Politics and trust. So some algorithms, especially every now and then, there comes a new algorithm out of the American government or something out of some questionable country that really gets pushed, and then people just don't trust it. They think that there's some backdoor in this algorithm. So when you select the algorithm for your solution, make sure you understand the politics and how the community feels about your specific algorithm. Okay, that's just something that I thought mentioning. I'm not going to go into the details here too much. Okay, 3 things that you should realize about signing. The first thing is that when something is digitally signed, these are you can know that it's authentic. You know for sure that this document was signed by the person who has the private key associated with the public key using to verify. There's no T's and C's. The data the integrity has remained intact. And the very important one is something called, it's implied, but it's worth mentioning, is something called non-repudiation. So, and this is one of the reasons why something like cryptocurrencies work. Because if I signed something with my private key and somebody has the signature, then me as the signer can't deny taking that action anymore. So it's merely this idea of when you sign something, it cannot be unsigned. Okay, that is, and yeah, it makes you. There's a lot of solutions for this. Okay, so why do you even want to sign data at all? With asymmetric keys, all that Alice could have done, she could have taken an envelope and she could have encrypted the whole envelope just with a private key. I mean, this is an argument. Then you can argue that you have the added benefit that that the data is encrypted as well. Well, there's a bunch of reasons, and these reasons are a little bit theoretical and they are practical as well. So encrypting datasets with RSA private keys is considered bad practice because a lot of people feel that it's unsafe. They worry about information bleeding out. You guys will remember there was a Heartbleed security bug I think it's a couple of years ago now. Now, this is not what happened, but it's just the same type of fear that people have. There's another issue that some algorithms simply do not allow for encryption with the private key, but this is a signing they do signing in a different way. Asymmetric decryption over large data sets is very processing intensive. There are ways around it. You can use something called session keys, but it is a concern, especially when you use hardware keys. Signing can lead to small envelope sizes. This is just, I can demonstrate that if somebody questions that. And most APIs don't support encryption with private key anyway. This is mostly because of the reasons I gave above. Okay, I hope that didn't go over people's head. Okay, so another reason is very simply the advantage that you can have one envelope with multiple signatures on it. And you can see a signature as kind of a blessing for an envelope. And that is the biggest advantage, in my opinion, that signing has over encryption. Never mind the other issues. Okay. So now we're at the last part of my talk. I don't know if I'm over time or under time, but but it should go relatively quick from here. And I want to talk about chains of trust. Now, and once again, I'm just going to try and give you guys an idea of how chains of blocks are put together. I'm careful not to say the word blockchain because the definition of that is formalized these days. Okay, so imagine that you're a truck at Cape Town Harbor, and somebody loads goods into your truck. Okay, and now what you do, and so imagine we've built a solution. This is a solution I'm going to explain. And so imagine you've built a solution. You made, so this block here, imagine that's like a class. You know, in programming you have a class, and this class contains the harbor master name. And then it has an array of cargo transactions. Okay, so what this basically says is this is where it happened, and this is what we did. Well, we loaded 1,000 boxes of cigarettes. And imagine you serialize this class into some data structure. Let's say you serialize it to JSON or something, and then you write it into a barcode. And you have to imagine a barcode is like a little flash drive that you can save a file into. Okay, so this data is in there. Now, see here at the bottom we say signature. So what I want you to imagine is that the harbor master or the institution at the harbor, they sign off, they create a digital signature at inside this barcode that verifies that this is what happened. Okay, and the user scheme, very much like I explained earlier. Okay, now nobody can change this, and this is printed on the paper. Okay, so now this truck drives, he drives to Bloemfontein, and there, this truck goes and he loads 10 bags of millies, is what he adds to his cargo. And he also adds to his manifest, 10 bags of millies is what's inside my truck now. Now we do something special. We copy the signature. This arrow is supposed to come from there. We take the signature that was produced in the previous block and we include it into our current block. Okay, and then we sign all of this data that's in here. Okay, when I say we sign all of this data, I mean we take all of this data, we hash it, and we sign it with the private key of the depot at Bloemfontein. I hope that makes sense. Okay, so now the truck drives along, and he rocks up at Bloemfontein, at Johannesburg, and there same thing happens. He loads 10 cases of beer, and he includes the signature from the previous transaction, and they sign it there. And the same thing again. And now they end up at Nelspruit, and you'll see the transaction that we do here is we unload all the cargo at Nelspruit. So now this truck driver has this document, and it has all these barcodes on it, and he has an empty truck. And now he can just walk to his boss. His boss can go, where's the cargo? And he says, here's the document, and here's my proof that all of these things happened. just by scanning these barcodes and look at the transactions, I have proof of exactly what happened. And since each one of these are cryptographically signed, there's no way of faking this. And if I wanted to fake this transaction, I will have to fake this one as well. And I'll have to fake this one as well. So there's layers of security built into the system automatically. Okay, so and you know, life is complicated, but that's okay. Chains can get complicated as well. So I'm just going to tell exactly the same story, but I'm just going to make it a little bit more complicated to give you guys a feel of the types of things that you can do. Same story. A different truck starts at Richards Bay, and there loads 10 bags of sugar. Okay. After I just realized that this isn't 10, this is 1, 2, 3, 4, 5, 6. But oh well, forgive me for that. And the Richards Bay harbor master signed the data structure, and they write it into the QR there. Okay, exactly the same story. And then they drive along at Ermelo. They decide to load a cow as well at Ermelo depot, and same idea. They include the signature from the previous step, and the Ermelo depot signs that this is really what happened. Okay, so now this guy, they both drive to. Imagine this truck and this truck. They meet up at Johannesburg, and what they want to do now is they want to. This truck can't drive anymore. The truck with the cow can't drive anymore. It's out of gas or whatever. So they want to load all of the cargo into the big truck. Okay, no problem. So what we do is this. We, at the Johannesburg depot, we just, we create, so just as before, we say, we have an entry for the previous signature, just like before. And in our cargo transaction, we write the entry, take overload from other truck, and we include the signature from the Ermelo depot into our transaction. And then we sign the whole transaction in the Johannesburg depot. And the driver can now, and this will manifest in this QR here. Okay, and this truck driver can now keep just both pieces of paper or a copy of the other one to prove that this is what happened. So, and now the truck can drive with, the cow can drive with this guy. And then the truck can go on to visit Nelspruit and do whatever. And this is the picture that I wanted you guys to have, is this idea that that blocks can these blocks can be chained using different keys, and they can, in this way they can protect a set of instructions. Okay, now the reason why I'm careful not to use the word blockchain for this type of solution is, as I just say, a chain of blocks, is because if you, these days they have formalized the definition of a blockchain to have something called a distributed ledger, which is something that I'm sure somebody will talk about in the next talk. But the idea that it's just the mechanism and where you store the blocks. Okay. Okay, so and in the story I told, we store the blocks on physical paper, because in my system that I demonstrate here is we build an absolutely offline system, which is very appealing to a lot of organizations, because they don't want other companies to know what they're doing. They don't want the system to be offline, or they're driving the truck through the Sahara, you know, there's no internet, or, you know, things like this. And it's a real solution. Okay. Okay, so that's my whole talk. Just some things I would have loved to talk about, but I just couldn't. I was going to run out of time. The first one is setting up trust relationships. There's something called public key infrastructure. You guys can ask me about it. The next thing is hardware keys. I'm sure you guys have seen UB keys being used. A UB key is effectively just a key store that stores a private key. It can store symmetric keys as well, but you know, that's a whole topic. There's the strategy of how you bit packing, how you store lots of data inside a small media like a QR. There's strategies for providing originality. You know, I spoke about the security features, the holograms, and the watermarks, those types of things. You know, there's more standards and different types of barcodes, and this GS1, which is an organization that manages all these things. But yeah, in my rehearsal, I ran out of time at this point, and I think I am out of time. So yeah, I'll just answer the question.